Okay, I'm just going to go through this question here, where we're going to simplify. Now, there's some basic rules that root A times root B is root AB. Also, root A on root B can be found by putting root A over root B. The other thing, just to note that, like, say you have 3 root 5 times 2 root 2, then you can do number times number, and then surd times surd. And then simplify at the end if you have to. So 3 times 2 is 6, root 5 times root 2 is root 10. Okay, so if you look at part A, you could do this in 2 ways. You could simply square root the 4 and you get 2, square root the 9, you get 3, so you end up with 6. Or you could go 4 times 9 is 36, root 36 is 6. Okay, this one here, the same. You could just go 4 9s are 36, which is 6, or you could go root 4 times root 9, which is 2 times 3, which is 6. This would be 2 5s are 10, because you can root 4 times root 25, and 2 times 5 is 10. So I think they're just trying to get you to do the difference. Root 16 is 4, root 4 is 2, 4 on 2 is 2. So you could go 16 on 4 is 4, and then square root it, which is 2, or you could go root 16, which is 4 on root 4, which is 2, which overall gives you 2. This is root 9, which is 3, and this is 9 on 3, which is 3. So it's just the idea that you can do something by working that out, or you could do it separate, or you could do it by doing that, or you could do it separate. And then apply that to anything. So you can do that for the nth root will equal, you can separate those, and in that, so that allows you to do, say you're doing that times 27, it's much easier to go the cube root of 8 times the cube root of 27, as long as they're the same, like you do it of separate ones. That would be 2 times 3, which is 6, and that makes it easier than doing 8 27s and then cube rooting it. Okay. All right, the same, say you did the cube root of 17 on 8, then that would be the cube root of 17 on the cube root of 8, which is the cube root of 17 on 2. Okay, so we're just going to look through this one. So what we're actually doing here, we're going to simplify these surds. And I think we'll also just look at root 18. So root 18 you write as root 9 times root 2. See, that can split it up as 9 times 2. So that would be 3 root 2. And root 28, okay, so that's root 4 times root 7, which is 2 root 7. Now, when you're actually trying to find the square number that goes into it, if it's something that's really big, sometimes it's easier to divide by 2 than by 3, then by 5, than it is to actually try and find the square number that goes into it. Like if you divided 98 by 2, you get 49. So that would be root 49 times root 2, which is 7 root 2. Okay, so root 32, so I'm going to divide 32 by 2, see, and I'll get 16. So that's root 16 times root 2, which is 4 root 2. 54, trying to find a square, I think it's 6 9s. And then make that root z squared. So the square root of 9 is 3, the square root of 6 you can't do, there's no square root, and the square root of z squared is z, because they're opposite square roots and squares, so that's z root 6. So this one you've got the square root of 8 on the square root of 49. The square root of 49 is 7. The square root of 8 is root 4 times root 2. So it's 2 root 2 on 7. Root 2 times root 3 is root 6. This would be root a squared times root b. Root a squared, they counteract to each other and you get a, and that's a root b. This is the cube root of 8 times the cube root of g times the cube root of h cubed. So the cube root of 8 is 2. Cube root of h cubed is h. So I'm just going to write that out the front. And that's the cube root of g, and I'll leave that underneath the root. This is the square root of a squared on the square root of b cubed. Okay, now that is an interesting one, because the square root of a squared is just a. But what's the square root of b cubed? Okay, is there actually a square number in that one? So if you think about it, see, it's b squared times b, isn't it? So that's the square root of b squared times the square root of b. You can split that up. So the square root of b squared is b, and the square root of b is just b. So there is a square number that you can pull out the front for that one. Gosh, that's it. Okay, all right, I'll just do this one in a different colour so you can actually see it. So I've got the square root of 27 times the cube root of 3. All right, so they're different roots, so you can't do much with them. But this is the square root of 9 times 3 times the cube root of 3. The square root of 9 is 3 times the square root of 3 and the cube root of 3. Now, I don't really know why they've got this question, but they're trying to show you that if they're different roots, you can't actually group them together. You could put all this in index form just for the record, because that's to the power of a third. I don't know if you know that what's at the door is on the floor. And you could write it all in index form, so a half plus a third plus 1. So a half plus a third would be 3 plus 2 on 6. So it's 1 and 5, 6, I don't know. But anyway, I think they're just getting you just to leave it like that. So with these, you're just looking for their mistakes. So all that they haven't done is they haven't simplified the root 45. So the root 45 is root 9 times root 5 nines are 45. So that's 3 root 5. So it'll be 3a root 5. That's how I'd write. I always like to write the number first. This one here, so that's the cube root. It's very hard to read that on my page, my eyes. So it's a cube root of 16 times root 2. So the cube root of 16, so you write that as root cube. A cubed is 8 times 2. So you've got to find a cube number that goes into it. The cube, so that would be the cube root of 8 times the cube root of 2 times root 2. The cube root of 8 is 2. And then you can't do anything more. That's why that's wrong, because one's a cube root and one's a square root. And I think that's the point they're trying to make. That is root 9 on root x squared on root y cubed. So root 9 is 3. Root x squared is x. And then it's the square root of y cubed. Okay, so what you could actually do there, you go x, you could pull a square out of that one. So it's y squared times y. So it's 3 on x, y, times root y. And that's as far as you can go. Okay, so when we're looking at this and we're simplifying it, 68. So if we get 68, I can't really think of a square number that goes into it. If I divide by 2, I get 34. That's not really getting anywhere. I think 4 goes into it. So I'm just going to try 4 goes into it once, remainder 2. 4 goes into that 6. Oh no, it doesn't, because I wrote 64. 4 goes into that once. 4 goes into that 7. Yeah, so it's root 4 times root 17, which is 2 root 17. Now, this one here, if you can use your calculator to do it, but if you're calculating this, if you break the 22 up into root 11, then the root 11 times the root 11 will actually give you 11, and because do you know that when you do root a times root a, that's root a squared, which is giving you a. So basically what's underneath the square root, if you multiply a surd by itself, you'll get what's underneath the square root. Like root 5 times root 5 is just 5. Root 7 times root 7 is just 7. Because 7 sevens are 49, and the square root of that is 7. When you're doing something with zeros, to get the square thing, you need to have, you can halve the number of zeros. So for example, if you had root 100, you get 10. But if you had root 1,000, you would get root 10 times root 100. See? So that would be 10 root 10. But if it had an extra 0, that would be 100, because you just halve the number of zeros. It's 100 times 100 to give you that answer. So when I'm looking at this, I would do that as root 1, 2, 3, 4 times root 10. And this one here I'd do as root 100 times root 10. So what I would do is I'd pull out, see how I've pulled out the even number of zeros? So the root 10s cancel, but root 100 is 10, and root 10,000 is 100. So 100 on 10 is 10. Okay, root 700 is root 100 times root 7, which is 10 root 7. This one here, a cubed, I'm just going to do it down here. So it's the cube root of a cubed times the cube root of b squared over the square root of a cubed times the square root of b squared. Now that one cancels and just gives you an a. That one cancels itself out and gives you a b. This is the square root of a cubed and the cube root of b squared. And you can't really do a whole lot more with those. You could take a square, like because you've got that one there, you could take a, so you've got a, that's the cube root of b squared. You could pull out an a squared, I guess, couldn't you? A times b. So that will give you a cubed root b squared over a root a times the b. The a's will cancel out and you get the cube root of b squared over b root a. That's about as far as you could take it. Okay, so when you're doing this one, you've got the even thing again, and we want to get a fourth root. So, you know, if you did a fourth root, then you'd need, if you did 4 zeros, it'd be 10, okay? Because the reason is, so you got 10 to the 4, and a square root is a power of a half. So really you're just halving the indice, okay? So that's if you're doing it to a square root. If you were doing it to a fourth root, so that would be 10 to the 4. You're putting 10 to the 4, you're taking the fourth, you're doing a quarter times the indice. So that would be 10. So this would be root 32 times 10,000. And you can use your calculator to get that, but that's going to be root 16 times root 2. And that one's going to be root of that, which is fourth root of that, which is 10. The fourth root, sorry, it should be fourth root. The fourth root of 16 is 2. That's the fourth root of 2 times 10, and 2 10s are 20. Okay, so if you have the square root of 15 on the square root of 12, there's not a lot you could do there, but you could break that up into root 3 times root 5, because in here we have root 4 times root 3. And see, the root 3's will cancel, so you'll have root 5 on top, and you'll have 2. You could also just, you can cancel a surd with a surd. So you could straight out go, oh, root 3 goes into that root 5 times, root 3 goes into that root 4 times, because there is a common factor of root 3 there. So that's root 5 over 2. Okay, so looking at L is the square root of A4. So you can think of that as index form too. So the square root is a power of a half. Halve the indice, you get a squared. Or you could write that as a squared times a squared, square root of. Okay, so, or a squared squared square rooted. What times itself will give you a4? The answer would be a squared. Okay, so the next one, m. So you got the cube root of 54, so cube root. So I'm thinking 27, because it's the cube root of 27 times 2. So when I'm thinking of cubes, I go 1 cubed is 1, that's going to be useless. 2 cubes 8, because it's 2 times 2 times 2. 3 cubes 27. 4 cubes 64. So I guess it's important just to be familiar with your cube roots with these. We don't usually go this far and do the cube roots. The cube root of 27 is 3. And usually we just deal with square roots. That should be cube root of 2, because it keeps the same root. But you can see it, any of these apply to cube roots as they would to a square root. So that's y squared z cubed. Okay, so let's break that up. The cube root of x times the cube root of y squared over the cube root of y squared times the cube root of z cubed. They're the same, so they cancel. So you've got the cube root of x over the cube root of z cubed. So those cubes just cancel and you just get z. Okay, so for this next one, we're just putting them back underneath the square root, like that one. Okay, so let's just look at something that's a little bit simpler first. So to put that underneath the square root, you square the 2 times root 5. So it's root 4 times root 5, which is root 20. When you're looking at B, if I said 5 root 2, you square the 5 times 2, square the 5, you get 25. 25 times 2 is root 50. So that's your basic concept. And now they've gone right in and we just do it straight with algebra. So you square the 2a when you're putting it underneath the square root. I'm just going to get rid of that. So what's that squared? 2 squared's 4, a squared's a squared, and then b. Okay, so let's look at another one. So root 7 times bc. So this one here has to go back underneath the square root. So it's the square root of b squared times root bc. And then if you multiply everything, then 7 times b squared times b times c, that would be the square root of 7b cubed c. Okay, so that's the answer to that's b. Okay, c. 6a root b on c squared. So make that 36a squared times root b on root. Now you've got to square it. So it's c squared squared, so it's c4. So that's going to be root 36a squared b over root c4. And then if you put it right underneath the square root, it's 36a squared b over c4. So it's like going backwards and putting it underneath the square root. Okay, d, 2b cube root of c. So square the 2b times the cube root of c, which is root 4b squared times the cube root of c, which is 4b squared. Oh, you can't do those because they are, one's a, oh no, I made a mistake. I should have put a cubed. You can do that. Silly me. And because it's a cubed, I didn't notice it was a cube. I did it on one, but not on the other. Let's go again. So because it's a cube root, you would have to cube that to counteract it, okay, to get the same thing. So if you cube that, you get 8b cubed times c. So it's the cube root of 8b cubed c. Okay, so e, b5 on b squared divided by 1 on root b. And we want to get it all as one root. So let's just simplify that first. B goes with b, and this is b5 on b times root b on 1. So b5 times root b would be b5 times root b. You add the indices, so that's 6. So that's b6. And on the bottom, we're going to make that root b squared. So then that's the square root of b6 on b squared, which is the square root of b4, because 6 take away 2 is 4, because you've got 6 of them on the top, and you've got 2 of them on the bottom. Okay, and this one here, square root of that cubed, fifth root of b10. Okay, so I might just simplify this first. So that's a cubed, because the fifth root of b10, if you think about that too, I think the easiest way is make it an indice. So that's to the fifth. So then you multiply those, or you could even do b to the 10 on 5, which is b squared, okay? I'm not sure if you've done this one where you do the nth root of a to the m is a to the m on n. A way to remember is at the floor, so that's on the is at the door, so that one matches, and what's on top stays on top. So that's why that 10 will go as an indice there, and the root will go on the bottom, and 10 on 5 is b squared. And if you think about it, b squared times b squared times b squared times b squared times another b squared would be b to the power of 10. So that's correct. So that's just going to be b squared. So if we now take that, we have a cubed times b squared, square it with a square root. So square it with a square root, and then you get root a cubed, so I'm squaring it, a cubed b, 4. And there was an extra little bit on this. This was the cube root of c cubed. Didn't realise that. So that's a cubed b4 times that counteracts and gives you c. And then you have to put that underneath the square root. So it's the square root of c squared, which is the square root of a cubed b4 and c squared. You certainly have good indice work after doing these.